rien, ni le bien qu'on m'a fait.
Initially, when the first CNC got built, Isaac didn't have any sort of dust collection system. He went to Harbor Freight and bought one of the cheaper shop vacs they had.
I was just holding that manually, and you can see in some of those early videos that it's just blowing dust everywhere.
Every time he used it, we had a thin coating of dust all over the workshop. Eventually, we 3D printed a dust boot that would attach to the CNC, which concentrated the shop vac right on the spindle head and allowed for a lot more dust to be collected.
The shop vac was pretty good at collecting dust once I installed that dust boot, but it had a lot of static pressure and not flow.
Even with the boot, the shop vac was not good at collecting chips from any sort of distance. One of the advantages of having a real dust collector is so much more flow is happening that the actual source of the suction can be pretty far away from the chips in the spindle, and you're still collecting everything. There was a long run of tubing that went from the CNC to the shop vac, and you lose a lot of suction with all that flex tubing.
The noise was also a huge drawback, where the shop vac was by far the loudest part of that system.
Yeah.
So it's not collecting a ton of dust. It's super loud. Obviously not a great long-term solution, but it worked all right for the time being. It was certainly better than no suction at all.
Isaac and I then moved to Motive's new shop. With the new shop came new opportunities and challenges for setting up the space. For the build-out of our new dust collection system, we decided to start with the Harbor Freight dust collector, motor, and filter. Unfortunately, the Harbor Freight tax on this product is pretty steep, but it's a good base and starting point for the build.
You get a solid motor set up with the Harbor Freight unit. All of the base things, there are obviously some good components that it just comes with for a really low price. There are certain parts of it that are pretty much junk. The filter bag.
It's the canvas bag.
Yeah, it basically has like pinholes in it that are blowing dust out and pumping dust around the shop.
I feel like using this filter is probably an OSHA violation. It's a canvas bag with large enough pores that our shop would just be a 2,000 square foot Beijing smog simulator. It's expensive, but we ordered a filter from Win Environmental that's MERV 15. You can see from this chart that it's a little overkill for wood chips, but we're also using it to filter out air from our laser cutter and welder. Just running the normal air in the shop through this filter would clean it as it comes out. The stand it comes with might as well be made from coat hanger wire.
Let me tell you about wire coat hanger wire. It is my favorite wire.
We used the dust collector for a little while in the cart it came with and just rolled it to each machine that needed dust collection. That was helpful during the shop's initial setup before we had the whole space planned out. We knew that we would eventually be mounting the whole system, and after a few weeks, Isaac had his design planned out and was ready to build. The build was based mainly around convenience. We wanted something fairly easy to set up.
So I just cut some plywood pieces on the first CNC, screwed and glued those together as a mount for our filter. So once the filter was up, then I could measure exactly where the peller and blower needed to be to line up with that. And then the main challenge was I wanted a system where we could easily empty it. So a lot of the times in people's setups, you have to do a lot of work to take band clamps off and all sorts of stuff to get a bag out, and then it's a pain to replace that. We wanted something quick and easy where we can just take a barrel off and then put that back on, hook everything up, and we're good to go.
We have a 30-gallon plastic drum to collect the large particles in the first stage. It has a rubber gasket and quick release clamp to seal it. To clean it, all you do is pull on the quick release, take the barrel out, and dump the chips in a trash bag. One important modification we needed to do was the impeller. The impeller, you say? How could Harbor Freight have possibly messed up an impeller? Well, first of all, it's the wrong shape and size. We purchased a new one with the correct diameter and geometry.
The blades on that impeller are in the reverse direction, so instead of focusing on airflow, it's focusing on static pressure a little bit more. It's a larger diameter, so it gets closer to the walls, so there is a increase in airflow as well, but the main benefit is that we get significantly more static pressure. So when you put your hand over it, or you have a long run of tubing, there's a lot more suction happening at the end of that vacuum.
After this, we used sewer pipe to connect all the machines back to the collector. For now, manual blast gates are being used in line to control where vacuum suction is being applied. We were careful when connecting all the pipes, making sure to seal them well. With 50 feet of pipe, small leaks all over the place could mean that we're losing out on a lot of our vacuum. We also avoided using sharp 90-degree bends in the entire run.
Anytime you can increase the radius of a bend, it makes that airflow a lot smoother and reduces loss. So we pretty much exclusively use 45-degree angles in our tubing and try and make sure that that air doesn't have to make any really hard turns, especially when you have heavy particles traveling with that air. They're going to want to go straight as much as possible where their momentum is already taking them. So the more gently you can turn those towards where we're collecting all the dust, the better. When you have a ton of really small particles moving at high air velocities through tubing, they're going to generate a electrical charge differential from the outside air, and so you'll get electrical shocks. Unfortunately, with a PVC system, you see a lot of people wrapping it in copper wire and putting copper wire on the inside, but PVC is not electrically conductive in any way. It's an extremely good resistor. So charge does not flow along the PVC. So you're basically only relieving charge where the copper wire is directly touching the PVC and nowhere else along the tube. Certain parts like the cyclonic separator, the filter, the motor, the impeller, all of that's grounded directly to our building, along with some of the other critical points like right as the system dumps into our waste bin. So we remove charge at those points where it could start a fire or have some sort of risk like that. But it's kind of a common myth that you can reduce charge of a PVC pipe by just touching a copper wire to one part of it.
The dust travels from each machine through the pipes down the wall to a cyclonic separator, then through the impeller into another cyclonic separator, and then diffuses out of a MERV 15 filter. About 95% of all the particles going through the system get trapped in that first cyclonic stage. The second stage is mounted beneath the filter and collects any fine particles that made it through the first. This also makes it easy to clean the filter because you use compressed air on the outside to blow it out, and the dust will just fall into the bag. The two stages mean we don't have to clean the filter out very often. So those are the main modifications we made to the existing parts. Other than the machines that are hooked up, some of the standout features of the system are the floor sweep, which allows us to sweep all the dust from the floor into a central port, and the integration with the CNC machine. Our CNC machine has a moving gantry, so we constructed a swimming arm to follow it. The pipe comes off the wall into a hinge, which allows the arm to move around with the machine. This, and the flex tubing at the end, makes it so very little torque is being applied to any of the wall mounts. Isaac also made a CFD-optimized dust boot for the spindle head. It has two parts connected by magnets to make tool changing easy and allows us to put on different brush lengths depending on the operation we're performing. We're also really excited to show you the design of the wall mounts that we used to mount the pipes to the wall. There was a really interesting design process that we went through using some AI-aided design to create a strong, lightweight, and inexpensive part. As we expand the system, we'll be setting up a fume hood and downdraft table, and that will allow us to best utilize the fact that we have a really great filter that can filter out smoke and fumes. So I hope you like seeing this setup and some of our dust collection history. Building out this system has made it much easier to keep our shop clean. Do you have dust collection in your shop? Do you have any tricks or ideas of anything that we can improve with ours? Please write it in the comments. We'd love to hear from you. And thanks so much for watching.